Okay, hello. We're going to have a little review before we get on to chapter 4. So let's start with quotient of powers. So if we have the same base in a fraction and different exponents, we take the exponent of the numerator minus the exponent of the denominator. And that'll work for any real number such that the base here is not 0 because we can't divide by 0. And m and n are integers. So let's do some examples. We have x to the 7th over x to the 3rd. So using our formula up here, we're going to have our base, which is x, to the 7 minus 3. And 7 minus 3 is x to the 4th. Rather than just memorize this formula, it's helpful to think of it as the uh, the theory behind it. So the fraction broken down is going to look like this. We have x times itself 7 times on the top and times itself 3 times on the bottom. That's what x to the 7th means, and that's what x to the 3rd means. Now, you know, if we have the same thing on the top and the bottom, it makes 1, so we can get rid of it. So there we go. We get rid of the ones that cancel. And what do we have left? We have x to the 4th left. So if you just use this to think, okay, I have 7 x's on the top and 3 x's on the bottom all times each other, 3 of those are going to cancel out and we're left with 4. Okay, now let's get a little more complicated here. We have some coefficients, which are regular numbers that just act like regular numbers. And then we have some exponents which follow this rule. Okay, so starting out, it's important to realize that if it's just a plain old variable, it's to the power of 1. So you might want to write those ones in. You don't have to. Now, let's get started. We have 40 divided by 8, and that's 5, because these are just coefficients, so we divide. Fraction bar means divide. Then we have x to the 2nd and x to the 1st. So to this 2 minus 1, which is 1, which we're big kids now. We can write it as x. Okay, and then let's look at the y's. We have 6 minus 1 is 5. And then we just put these three together. We get 5xy to the 5th. Okay, so that's just a quick review of quotient of powers and rules for simplifying exponents in fractions, which will come in handy later. And moving on, let's talk about multiplying polynomial by a monomial. So we're just multiplying, just like if it was a regular number without the x. And the important part, oh, sorry, forgot to put arrows. Then, remember, we're multiplying the coefficients and we're adding the exponents. Okay? So, 2x times 7x squared, 2 times 7 is 14. X to the 1 times x to the 2 gives us x to the 3, or x to the 3rd power, or x cubed. Not 3x. That's 3 times x, and it's totally different. Okay, so then we have 2x times negative 3x. Remember that negative sign goes with a 3, not with a 7. So 2 times negative 3 is negative 6, and x times x is x squared. Then finally, we have 2x times 5. We get plus 10x because 2 times 5 is 10, and we just get that little x carried along. Okay? Now, multiplying binomials. So, a lot of times people will say, oh, you can just FOIL it, which means first, which is the F, outer, which is the O, inner, last. This is just a order of how to do this. Okay, so first we did 3y times 5y, which gives us 15y squared. And then outer is 3y times 4, which is 12y. Inner is 2 times 5y, which is 10y. And last, we just have 2 times 4. Okay, so now we have our 4 terms. This is super important. FOIL only works when multiplying a binomial, which is 2 terms, times another binomial. Okay? If there are more or less than 2 terms, it will not work. So what I might suggest to you here is to do this method here called the box method, where you make a box. And then you say, okay, I have a binomial, so 2 terms times another 2 terms. So I'm going to have 2 rows and 2 columns. And then you're going to put one polynomial on the top and the other polynomial on the side. And then each box fills in with the row times the column. And it can be done in any order. So what you're going to do is to fill in your box, you multiply your row times your column. So 5y times 3y is 15y squared. Oh, we could do this one next. So 4 times 2 is 8. 5y times 2 is 10y. 4 times 3y is 12y. What you'll notice is these are the exact same numbers we got by doing FOIL. The nice thing about the box method is it works for any size polynomial times any other size polynomial. So while FOIL only works for 2 terms times 2 terms, the box will work for 16 terms times 16 terms. And you won't lose a term because you have to fill in all your boxes. Like it would be very obvious if you just skipped a box. The other nice thing is if you write the polynomials in descending order, which generally they'll be given to you as, then these two are your like terms. And we have to combine our like terms. So then we have 15y squared, 10y plus 12y is 22y, and 8. And right there, you come up with your answer. So if foil is your bag and it totally works for you and you can just groove along with it, great. Otherwise, might try the box because you can do it for all polynomial multiplication. So on this one, it's x minus 2 times itself. That's what the 2 means. And we're just going to do this by box method again because I like box method and I think foil gets a little confusing. So we're going to have a 2 by 2 box. We're going to fill in the top and the side with x minus 2, and then fill in our blanks. So x times x squared, negative 2 times x is negative 2x, negative 2 times negative 2, positive 4. Again, these are our like terms. Negative 2x plus negative 2x is negative 4x. And x squared minus 4x plus 4, that's our answer. Okay, I hope this was clear. If you have any questions, let me know. Your homework is in Math Excel. And those of you working remotely, I look forward to seeing you again soon. All right, have a great day. Bye.